Alright, what's up, goons? I hope you guys are having a good day. Oh, hello. Obviously, I am not there today, but we still got some stuff to learn. So we're going to have 2 days where we are actually learning all the stuff and the things. And then when I get back, we will be able to talk about some of these things. So all these videos will be broken down into different parts. This first video, we are going to talk about greatest, if I could spell greasiest, greatest common factors. Yay. So we're going to talk about some greatest common factors. Now, you should have gotten a piece of paper where you will be taking notes on this. This is one of the easiest daily grades you can possibly get. So make sure that you are going along and taking these notes. I will take up these notes and look at them to make sure that we actually got something out of this day. So make sure you're getting all of the things that I am writing down onto your notes. If not, there will be points off. Come on now. Alright, greatest common factor. We know greatest common factor by an abbreviation, GCF. We've actually been looking at greatest common factors. It was part of our factoring, or not factoring, or completing the square process as we were going from standard form into vertex form. Now we're going to look at a bunch of different applications of GCFs. Greatest common factor, the actual definition, is the largest number and variable pair that can divide evenly into something else. Neat. Now, you have taken a long while since we've actually talked about GCFs as it comes to factoring, so let's start off real basic. What if I asked you to find the GCF between 32 and 24? I want the greatest common factor between 32 and 24. Well, the greatest common factor is the largest number, there's no variable here, that can divide evenly into both of these numbers. Now, there is a trick to this. In my calculator, I can actually go to the y equals and type in whatever number I'm looking at divided by x. If I go to my calculator and I do that, I can go to my y equals. Let me see if I can get it out of the glare. Take 32 divided by x and go to my table. In my table, I see all of the factors, the pairs that multiply to give 32. Boing, 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 boing. Boing, 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 boing. So here are the numbers that divide into 32. I could have a 1 and a 32. I could have a 2 and a 16. A 4 and an 8. We're not going to use the decimals because those don't divide evenly. I keep scrolling, and I see 8 and 4 again. I already listed 8 and 4, so no, I'm done. Let me do the same thing with 24. So y equals 24 divided by x. Go to my table. Looks like my factors are 1 and 24, 2 and 12, 3 and 8, 4 and 6, skip the next decimal, and 6 and 4 repeat, so I'm done. Now I'm looking for the GCF, the biggest number that divides into both of those numbers. Well, I'll go through my list. What is the biggest number that appears on both lists? 8. So in this case, 8, the GCF is 8. Now this is the baby steps. This is the getting what the heck is going on steps and going from there. I can also do this with variables. If I asked you to find the GCF there we go, between x squared y and x cubed y squared. Well, this pair has 2 x's because it's x squared and 1 y. This has 3 x's and 2 y's. So this one has 2x and 3 x's. The biggest or largest amount of x's that they share is 2. They don't share 3. This one only has 2. The largest amount that they both have in common is 2. So part of my GCF is x squared. The largest amount of y's that they have in common is just 1. So my GCF is x squared comma y. Again, greatest common factor is just the biggest variable and number that could go in evenly to both of my things I'm looking at. So, crash course on GCF. Where we use this in factoring, and honestly this is the easiest version of factoring, so we're going to title this video Factoring version 1. Factoring V1. GCFs. Easy mode. Let's say I gave you 3x minus 12, and I told you to factor. Well, I see that this is a 3x and a 12. They don't share any variables, but I think there's a GCF between them. The biggest number I could divide into both 3 and 12 is a 3. So, this 3 that I'm dividing out is the GCF. It's the biggest thing that 3 and 12 have in common. That GCF goes on the outside, and I divide to get the inside. 3x divided by 3, I'm left with x. Negative 12 divided by 3 is negative 4. BAM! That's it. That's all you have to do for this factoring. Soup's easy, totally doable, yet you will still panic when you run into these kind of problems. They're totally fine. What about this? If I gave you 4x minus 16, and I said factor. Well, there's nothing else I can do here. They don't share any variables, so all I'm going to look for is a number. Looks like I can divide 4 into 16 and 4. Notice I could also divide 2 into both of these, but I'm not going to divide by 2 because I'm looking for the greatest factor. I don't know why I give it a big p at the end of it. The greatest factor. Yes, 2 would divide in there, but 4 is bigger, so I'm going to use a 4. Again, the GCF goes on the outside. 4x divided by 4 is x. 16 divided by 4, or negative 16 divided by 4, will give me minus 4. That's all we got to do for these. Greatest common factors. Very, very easy. Now, where this can get a little bit more complex is when I start throwing variables in here. What if I gave you x squared plus 12x? Well, there's no number up here, so there's an imaginary little 1. 1 and 12, the biggest number that divides into there is just a 1. but this is x squared and this is x. They both share in x. So I'm going to divide by x. That x goes on the outside. I'm left with x squared over x. 1x cancels. So I'm left with x. Just in case this is x and x. 2x's on top, 1x on bottom. Cancel. 12x divided by x. The x's cancel, so plus 12. Again, very easy if I'm still factoring. Still factoring. Let's do one more easy version 1. Factoring. Let's say I have, let's go 5x cubed minus 45x squared. Okay, look at the numbers first. Biggest number that divides into 5 and 45 looks like it's going to be a 5. This one has 3 x's. This one has 2 x's. So the biggest amount of x's that they have in common, greatest common factor, are 2. So 5 divided by 5. Oh wait, oops. You will make the steak as well. Make the steak. Put the GCF on the outside. 5 divided by 5 is 1. X cubed over x squared will leave me with just one lonely x. Negative 45 divided by 5. You do not need a calculator for that. Calm down, children. Minus 9. X over x. Or x squared over x squared. Cancel each other out. So I'm left with x squared, 5x squared on the outside is my GCF. And x minus 9. So, this is my GCF. Fairly easy to identify because I'm just going to pull out big parts. If you are still listening to this video, go to the top of your notes and put a little star next to your name. Now, at this point, if you are an L student, stop worrying. You can go on to the next video or go on to the practice. My K kids, this can get a little bit more complex, and I want to show you what waits for you beyond the 7 C's. What if I gave you something like this? Let's say I had 12 a squared b minus 36 a cubed b cubed plus 18a squared. Again, I'm going to go through and see if I can find the biggest variable exponent combination along with my coefficients, my numbers. So let's start with the numbers first. 12, it's divisible by 6 and 4. 6 goes into this one. 6 also goes into that one, so let's try it. 6, a squared, a cubed, a squared. They all share at least an a squared. B, b cubed, and b, oh, no b. So nothing else. See what I get. If I divide that out, I have 6a squared. 12 divided by 6, that gets me 2. A squared over a squared, they cancel. I'm left with ab. 36 divided by 6, that's going to give me a negative 6. A cubed over a squared, that's going to give me an a. B cubed. And then 18 divided by 6, I'm going to get a plus 3. A squared over a squared, they cancel out, and boom. Still not bad. Still doing our thing, still chugging along, still being awesome. What if I started throwing really weird symbols at you? Which I totally could, but I probably won't do it often. Throwing symbols at you. Nice. That was me throwing examples. And by throwing examples, I mean I just threw pencils all over my desk. Now there's a mess. Wait. Why am I the way that I am? Help. What about this? Oof. Alright. Well, the idea of GCFs stays exactly the same. I'm looking at the number first. 3 and 18. Well, I'm thinking I can divide a 3 into both of those. They're both divisible by 3. This has an x, this has an x squared. So why don't I pull out an x? Now, they also share this dy line dx thing. They both have it, so why don't I pull that out as well? Anything that they share, it could be a complex something like this, it could be a number, or it could be a variable. Anything that they have in common, I can go ahead and get that bad boy out. So on the outside, I have 3x, this weird gross thing dy dx. 3 divided by 3 is 1. X over x cancels. Dy dx, they cancel. So I'm left with 1. 18 divided by 3 is going to give me 6. X squared over 1x is going to leave me with 1x. Dy dx over dy dx, they cancel away. So I'm left with this. All this is meant to show you is it really doesn't matter what's there. If there is something there, I can pull it out and I can go throw it up front. Throw it up. Like someone vomiting. This is the GCF that we just threw up. Alright, neat. That's the end of this video. You can go on to your practice. Once you finish the practice, you can go on to your next video. Deuces.